All right, hello guys. This is AP Calculus BC Lesson 4-2. We are on P series today. So just as a review for our procedure, if you want to participate in class, you give me a yes. If you want to ask a question for me to like stop everything I'm doing to answer your question, it's a raised hand. That's the difference between the two. So with someone giving me a yes in the chat, can someone read our objective today? No one? All right, well, I will read it. Our objective today is to determine if a P series is convergent or divergent, and that's using both sigma notation and the expanded form. So our question today is, what is a P series? So if I add 1 plus a half plus a third plus a fourth, and it goes on a fifth, a sixth, a seventh, and it's an infinite series, right? It never ends. It goes out to infinity. So eventually I'm going to be adding 1 over 1,196, all those numbers out there. The question that you should be thinking in the back of your head right now is based on our objective. Is this P series I'm listing right here, is that convergent or is it not convergent? So everyone has to use the participants, the nonverbal feedback. Everyone give me a yes or no. Do you think 1 plus 1/2 plus a third plus a fourth, if I add those all together, I mean, it's getting smaller and smaller, right? Does it converge to a number or does it not converge? Does it eventually go to infinity? So either saying, yes, it converges to some number, it might be like 1.9, or does it diverge? You're saying no, for it diverges, it eventually counts up to infinity. And you guys are right, it actually does not converge. So we can say that this diverges. Why? I don't have time to get into it today, sadly. I can show you the proof. I can also just assign you the proof on Khan Academy for you to read through, but it's pretty straightforward. This also has another name, I think, and my wife is behind me. She can correct me if I'm wrong, but this is also called the telescoping series also. So this is another form that you might see. This is called a sigma notation, and this capital S in the Greek letter is S for sigma, right? And this means sum. So I'm summing 1 over n starting at 1. So let's plug in 1. That's going to be 1 over 1, 1 over 1. Plus, okay, then this index right here, this n is called the index. This index is going to increase by 1. So now n is 2, and I plugged it in 1 over 2. 1 over 2 plus, okay, and then I'm going to plug in the next index, 3, 1 over 3 plus 1 over 4 plus, and it goes on and on forever. And you'll say, oh, that's the same exact series that we had up above. Yeah, these two are equivalent. You've probably already seen that from yesterday's homework, but I'm just making that extra clear. And no one is raising their hand, so I'm going to continue on to the next one. So what happens if I change this a little bit? What if I make this n squared? Then I'm doing 1 over 1, because I'm plugging in 1, and that's really 1 over 1 squared, which is 1 over 1, plus 1 over 2 squared, that's going to be 1 over 4, plus 1 over, and then the index is going to increase again, 1 over 9, plus 1 over 16, plus, and it continues on and on because it goes for an infinite number of terms. By the way, this number on top is counting how many terms do I have. All right, so that is another type of P series. By all of these are considered P series. And this one does converge. So this one up here, we already know that this is diverges because these are the same. I can do an arrow or a Claire, as we're sometimes calling these. These two are the same exact sequence, so therefore they diverge. But this one actually converges. It converges to a value, and I could tell you what that value is, but I don't care so much in this lesson on what that value is. I care more, does it converge or does it not converge? That's the only question that I'm asking. And if you're really curious, you're like, wait, why does it converge? Then you really need to look at the proof. That's the best way to explain this. And if you guys want, I can make my own version of the proof. It's basically going to be a rehash of what Solomon Kahn does on his video, because it's the easiest proof that I know. And then finally, what if I change this power to any power? I can have a power of 3, a power of 4, a power of 5, any power that I want for P. And I can also choose fractions or negative numbers too. I could do a 0.8 or 1/5 or -3 or -1 over 3. I can choose any value that I want for P as long as it's in the real dimension. I can't do imaginary numbers. AP calculus is always restrained within the real area, but you can do calculus with imaginary numbers. It's kind of a fun thing to do too. But I can choose any value for P. So technically, the way that I write this out is 1 over, I first plug in 1 to the power of any P. So that P could be 2, 5, again, whatever it wants, and then plus 1 over, okay, it increases to 2 to the power of p, plus 1 over 3 to the power of p, plus, and it continues on and on. And now we don't know if this converges or if it converges or diverges. It's really all based on that power of p. But I want to make sure that we really understand this is a p series. A p series generally looks like we're adding a bigger number to the denominator, but that denominator might be raised to some power, and it could be a fractional power. So you might not notice that it's a p series. So this is what I'm going to say in my notes. All of these things that I'm talking about, all of these are a p series in some form or another. All right, welcome, James. So our question to get to our heart of our objective is, when does that converge? Because I said it diverges when this is to the power of 1. It diverges when it's to the power of 2. And generally speaking, this is just the form that you have to remember. If you have a p series, so you have to remember this is the general form of a p series, and I'll write that up here. This is the general form. So if I'm talking about this general form, that converges when p is greater than 1. That's it. If it's bigger than 1, you're done. And therefore, the opposite is true. If p is less than or equal to 1, then it diverges. So that's the end of the new material in terms of teaching it. But let's apply the teaching. Let's apply our new knowledge to see if we can talk about some of these problems. And I'm realizing some of these problems are almost exactly like you'll see on Khan Academy. You'll be like, oh, this is exactly example 2, and then you'll get the answer, because there's not that many variations that I can make to make it that hard. It's going to be basically the same type of question. So here we go. And this is where I definitely need people to be participating. So you're going to give me a yes if you're ready to participate, or a raised hand if you have a question again. So example number 1, does this series converge or does it diverge? You can just circle one or the other. There's not that much math that you have to do. You just have to analyze what is the value of p. What is the power? I only care about the power. So give me a yes if you think you have an answer. I should see at least 4 people giving me a yes. So far, no one is. And I know that you guys are probably frantically copying this down because you probably don't have a printer, or maybe you got here a little bit late. You didn't get here at 11 o'clock. You got here at like 11:05 or something. Looks like Eva has a yes. Gio has a yes. Teflon has a yes. I still only have 3. I'm going to wait for one more. There's the 4th person. Okay. I'm going to call on, let's do Eva. Go for
it. Does it convert?
It does. Why?
Because p is greater than 1.
There it is. Converges. And it's because our p value here is 3, which is greater than 1. Done. Yeah, thank you, Eva. And then if you guys want to get rid of your yes, I think you have that ability. Otherwise, I'm assuming that if you leave your yes on there, you're ready to do example number 2. So, and then you can hide your yes, of course. All right, so example number 2. Now I have 1 plus a 4th plus a 9th plus a 16th. So it's a little bit harder to tell what the series is doing, but it should always tell you in some form or another the general form. So I'll always tell you the general form on the tests, on Khan Academy's homework. Yeah, you'll always see what's happening. If you can't find the pattern, it tells you the pattern. All right, who has an answer for this one? I'm going to wait for at least 4 people again to give me a yes, and then I'll call from one of those 4 or more. So far, Arrow has her hand raised. And you guys can probably see that too. I don't know why I'm listing it out. Maybe for the video recording. Yeah, does that series converge or does it diverge? Eva has her hand up. Arrow has her hand up. Waiting for 2 more people. Giving you time to copy down the notes, 1 and 2, to think about this problem. I don't think it's that hard of a problem personally, but again, I might have, what is the syndrome called? Is it called master syndrome? It's when you've done a subject so many times that you don't know how to think about it from a newbie perspective. Yeah, Fiona, you have a question?
Oh, no, I have an answer.
Oh, if you could give me the yes instead of the hand up. Hand up is for a question, and then yes is for ready to participate. Cool. So now we have 3 hands raised, or 3 people ready to participate, I should be saying. I need 1 more person to be ready to participate before I can call on someone. 1 final person. And I'm going to call on someone new. There's Stego's hand. All right, so I'm going to call on, Fiona.
It converges
Yes, why?
because p is greater than 1,
Yeah, what is the value of p?
2.
Yep, p is 2, which again is greater than 1. Done. Yeah, thank you. All right, and I'll clear these. If you say go slower in the nonverbal feedback, I will go backwards. But otherwise, we're moving on to example number 3. I'll try to leave as much on the screen as possible. All right, so example number 3, we have some square roots happening now. And still we're dealing with the expanded series. We're not dealing with the sigma notation. We're eventually going to be doing that in example 4 and 5. Yeah, but for right now, just doing example number 3, the expanded form, our last example with expanded form. You can probably guess if it's going to converge or diverge just by the pattern of me choosing converge, converge, but maybe not. This power is a little bit harder to find because even in the generalized rule 1 over the square root of n, there's still not a power that's there. So you have to convert this into exponential from exponential form from radical form. All right, I have one hand raised, so thank you, Fiona. Again, I'll call on someone new. So you're Eva and Fiona. Thank you for raising your hands. You guys are safe until everyone is in. Or maybe I'll switch it up and I'll just call on you. Maybe you're just raising your hand to make yourself look good. No, you guys probably know what's going on. Waiting for at least one more hand for this one because it is kind of difficult. Is it going to converge or diverge? That's the main question. And I'm going to ask you why. Just waiting for at least one more hand, and it's probably going to be the person that raises their hand. Yeah, okay, so Andrea, does it converge or does it diverge?
It diverges
It does. Why?
because it's to the power of 1/2.
Exactly, yeah. So this is really written as 1 over n to the power of 1/2. That's how you convert radical form into exponential form. And as you said, so I'll say down here, because p here is 1/2. And 1/2 happens to be less than 1. Or I can say it's less than or equal to 1. That's when it diverges. Cool, yeah, thank you, Andrea. All right, and no one is raising their hand in the nonverbal feedback, so I assume everyone has the understanding that they need. So I will move on to example number 4 then. Ooh, it's in sigma notation, which I think personally is easier because you don't have to interpret the pattern. The pattern is right there. Yeah, James, did you have a question?
My question was that do I need to focus on the first 3 fractions, or do I just focus on the 1 over square root of n?
So on the AP test, they might be giving you something like 1 over square root of n, or they might be giving you one or the other. So make sure that you understand both. But strictly for my class for this year, for your non-AP class, you should probably just be focusing on the generalized form because that's always going to be given to you, and that's the easiest way to tell what the answer is. But sometimes you might have to discover what that fraction is. So like if I'm talking to Stego, Geo, and Arrow right now, player if you're watching the recording, you do need to pay attention to this too. You might only see that. Yeah, good question.
Okay.
All right, I'm moving on to question number 4, and I'll leave question number 5 up here if you want to copy it down ahead of time. So question number 4, does this converge or diverge, and why? So I'm looking for at least 3 yeses out of 8 people. So 3 yeses who want to tell me if it converges or diverges. Again, I'll be calling on someone new, and I might have to cold call on someone. And in terms of writing this down, I know that I'm not doing it because I already have it typed out, but sigma can be written one of 2 ways. The sigma notation, you can write it with teeth. It looks like this, or you can do the lazy versions with no teeth. I like teeth because it makes it look nicer. And I know if you watch Khan Academy's videos, I was watching how he writes his sigmas, and he does that bar first and then does that. And it does make it look better because it's a horizontal line, but I guess practice makes perfect. I'm still waiting for at least 3 hands. I have 0 hands so far. Does example number 4, does that converge or diverge? I have Gio's hand up. I need 2 more people, giving you the amount of time to copy it down and also answer. Andrea has her hand up. One more person, and then I'll call on someone. And then there's James and Eva. Okay, cool. Let's go with Gio.
Great. All right. It diverges
You're correct. Why?
because the power is less than 1.
Yeah. The power is? Oh yeah, 0.8, which is less than 1. Yeah. So P is equal to 0.8, which is less than or equal to 1. Thank you, Gio. And I'll go ahead and clear these again. So that's example number 4. And our final example is example number 5, which is about as hard as I can give you. It's sigma notation, which looks scary. I have a radical instead of exponential form. So example number 5, does that converge or diverge? It has a 7th root of n in the denominator down here. And I need to call on someone new. Fiona and G already have their hands up. So I'm going to do first come, first serve, whoever is the first new person. We have 4 people that have already participated, so thank you for raising your hand, letting me know that you know how to do this. So go ahead and finish this up. Say it diverges or it converges and have your reason. And then you can just go on to Khan Academy right now. You don't have to wait for us. I need someone new to answer this. So that's between the Stephanies, James, and Arrow. I haven't heard from them yet. I think I might have made a mistake there, but someone new. Does that converge or diverge? All right. Yeah, let's go with Arrow.
Okay, so it seems like it's less than 1, so that would be converges.
What is the power that you found? P is equal to
Something that's less than 1.
something that's less than 1. You're correct. And if it's less than or equal to 1, then it.
Oh, that's the important part. Then it diverges.
Indeed, yeah, it does diverge. And it diverges because P in this case is less than 1. Is there someone that can tell me what that value is? Can we go to Eva again?
Wait, what?
What is the value of P in this case?
Is it 1/7?
It is 1/7, yeah. And as Arrow said, 1/7 is less than or equal to 1. And just so that everyone can convert this, this is 1 over the power of n to the 1/7 power. Cool, thank you guys. That concludes lesson 4-2 for AP Calculus BC. So I'm trying to stop the recording.